This is Jeff Jalbrzikowski. He is with NOAA and NGS. He is here now. It's surprising. I didn't realize we had him one amongst us, but we do. He's a flat earther. And he's going to talk to you a little bit about how SPCS 2022 is making Earth flat again, one zone at a time. Take it away, Jeff.
Indeed. Thanks, Tom. Thanks. Just a quick little story for everybody. We actually got a request not long ago at NGS, came through a couple of us to talk with someone, I don't remember who it was, that did a podcast that was going to host some flat earthers. And they had said, we'd like you to come talk to them. And all of us that were asked were just kind of like, no, I don't really want to do it. It's like, how do you change someone's mind who's got that something so far-fetched in it? Anyways, hopefully he had a good podcast, or maybe he had some fun. I never figured out if it was supposed to be a parody or for real. So a little bit about NGS real quick, who we are, what we do. There we are on the bottom of the screen. So we're a small agency, about 170 some strong out of almost 50,000 within the Department of Commerce. I only throw this up here because I want to say not only who we are, but I like to mention who we're not. Cindy Rachel was on earlier from USGS. Whoops. We're not USGS, we're NGS. I just like to make that distinction because I've heard a lot of confusion over the years. So we're over here on the left, that's us, part of NOAA. USGS is the 3DEP program, the 3DHP, number of other things that we work together with them where we can, but we are a whole separate department, separate agency. So what's our mission? That's it, the big, bold, red letters right there, the NSRS, or the National Spatial Reference System. The most common piece of the NSRS everybody's familiar with is NAD83. Okay, so we define, maintain, and provide access to the NSRS. The access is putting those monuments on the ground or getting those cores, those continuously operating reference stations, getting access to that data, or giving the public access to that data. I love this little graphic. You've all seen it over the years, right? Maybe this is what got you into GIS, right? The little layers graphic with the parcels, the elevation data, all that. Well, there's the NSRS. That's us on the very bottom, not the least important, but the framework for everything else, right? Without the geodetic control network, or without a datum, right? Without a universal datum that everybody can use, GIS work, as we all know it, would be highly inefficient, right? It would all start with just aligning your data. So we are in the process of modernizing the NSRS. Really what that means to most people is updating all of the NSRS coordinates. So NAD83 and NAVD88 coordinates will all be updated to new horizontal and vertical datums. But along with that, those new datums, or really along with the new horizontal datum or reference frame, which we'll mention, we're replacing the SPCS, or State Plane Coordinate System, of 1983 with the State Plane Coordinate System of 2022, okay? And there's another number of other items that we could talk about for hours, right? But really, the biggest thing I want to cover today is that SPCS 2022, and the fact that working in the future datums, even if you're only doing it through SPCS, you will need to be accounting for your coordinates changing with time, okay? Even if you're not working, people say, oh, I don't work in lat long, Jeff. I do everything in state plane. None of this matters to me. Not true at all. State plane coordinates are tied to a datum. And just to close out on this slide, we're talking about rolling all this out in 2025, okay? So NatRef 2022, or the North American Terrestrial Reference Frame of 2022, is what will replace North American datum of 1983. Why the verbosity? It's semantics, I don't know, scientific terminology, consistent terminology. I shouldn't joke about it. Really, the reason for that big verbiage change or wordage change is really to be more consistent with the international community. We're a federal agency that provides data and support to that international community of geodesy and GNSS and all that. So we're trying to harmonize with what other countries and other entities are saying and doing. The catch here when I talk about NatRef, if I know the NeoGeo Symposium brings in folks from all over. The last time I was in there was a couple from Canada, I think even. I think Tom had said. So technically, I want to mention that not just NatRef 2022 is what will replace NAD 83, but it's 4. I guess I should have said 3 sister TRFs here. Let's just go to the next slide. So along with NatRef, right, which is what the vast majority of anyone in the lower 48 will be using, there will also be a Pacific, a Caribbean, and a Mariana terrestrial reference frame. So far west coastal California, some folks may be using PATREF 2022. CATREF will be, Puerto Rico, etc., right? Mariana, way out on the Marianas Islands. So vast majority of folks, again, North American terrestrial reference frame of 2022, or NatRef, is what will replace NAD 83. I want to go through this animation because people identify with it. I guess it makes things click for a lot of people. So I like to look at it. But what I want you to think about here is, so we've got 2 different TRFs in mind here, right? They're terrestrial reference frames, right? We have our plate fixed NSRS TRFs, mainly NatRef, North American Terrestrial Reference Frame 2022, right? It's what we're going to be looking at. But we're going to compare NatRef to the ITRF, the International Terrestrial Reference Frame. What makes them different? The ITRF, our frame is constant. It stays fixed. And the plate, the North American plate in our example, is rotating. With NatRef, it's the opposite. So with ITRF in blue, we'll look at this slide, right? So we've got a constant frame and a rotating plate. That right there is how you can envision how the ITRF works. And I mean, this would be thousands and thousands of years of tectonic plate motion, but there you go. So you've got a frame that's constant, the blue frame fixed in place, while the North American tectonic plate rotates. And it does indeed rotate in a somewhat counterclockwise motion. Compared to NatRef, we got the opposite. Our frame is rotating constant with the plate, okay? That's where we come up with that term plate fixed. You saw me say that. You may have heard that before from NGS, right? So we've got a rotating frame that moves constant with the plate, or it's plate fixed. That's the idea behind NatRef and the other 3 TRFs. It's just the direction of rotation would be different for the different tectonic plates, okay? Great thing about this is if you know your epoch, you can move your data between any of these 3 or any of these 4 NSRS terrestrial reference frames, or TRS, and that ITRF, okay? But the key is you've got to know your epoch to be able to move data between the 2. I know after a while this one gets hypnotizing, so I'll move to the next slide. And so when I talk about moving coordinates through time or knowing the epoch, I want to go over some terminology real quick. A conversion up here at the top in green, that's when you change the type of a coordinate. So moving from lat long to SPCS. A transformation is when we change the datum of a set of coordinates, right? So moving from NAD 27 to NAD 83, or vertically NGBD 29 to NABD 88. So we got that a conversion and a transformation. Well, what's this bottom set right here? That's when you change the epoch of a coordinate. We call it a propagation. That's another international standard. It's an ISO standard. Somebody said, where'd you come up with that? I said, I didn't come up with it. It's an ISO standard of propagation, changing the epoch of a coordinate. So moving that coordinate through time, right? From a fixed reference epoch here, 2020, to this continuous or dynamic epoch. So how would that work? Let's take a little detour on this slide. So you would get data sometime around now, right? In NatRef 2022. In the future, maybe you get it from a company who's doing a survey for you. And maybe they use a real-time network. Maybe they used Opus, whatever. They've got these coordinates. You get them from them. It says, oh, yes, they're NatRef 2022, but it has this epic date. Now what do you do? What you're going to do is you're going to move that data back through time. You're going to propagate it back to this epic date, okay, which is probably what the rest of your data is going to be, right? Is the initial NatRef 2022 epic of 2020. Okay, so you're going to take new data, move it back in time to match your existing data in your database, propagating coordinates. Real quick, what's the shift look like across the lower 48? So across Ohio, we're talking about 4 feet of shift in the northwesterly direction. Okay, so our estimated geometric change, moving from what? N8083 to NatRef 2022. And remember, with a new horizontal datum, there must come a new set of state plane coordinate system zones. The way I like to think about it is what I've been saying for a while. And yeah, I'll be selling these bumper stickers on LinkedIn. If you look me up, it's the title of this presentation, right? Making Earth flat again, one zone at a time. Really? No, not really. If you remember the old Tostitos commercials, right? So SPCS 83, what does it look like now in the state of Ohio? Let's take a look. The north and south zones. What are we looking at though? What is this color shading? That's what I need to stop and explain. So this is linear distortion. Let me grab my little highlighter again here. So we're looking at linear distortion, okay? What is linear distortion? The simple way to think about it is the difference between a grid and a ground length at that location, okay? The difference between grid distances and ground distances. If you've ever worked with data from a surveyor and tried to incorporate it, or parcel data, or survey, boundary survey data, and tried to incorporate it into your parcel database or something, you may have encountered this, right? The grid versus ground. So what are we looking at here? Again, north and south zones. And unfortunately, my scale bar, I don't want to tell a huge long story, but this is a fresh map. But we didn't quite nail what we meant. So the scale is a little bit different on this one, the color shading, than the rest of the maps. But the goal of SPCS 83 was to provide linear distortion within a plus or minus 20 parts per million. You know, for most of the states, it didn't really do so great. If you could see, I mean, there's a few areas, right? But this was done way back, right? So nowadays, what are we doing? SPCS 2022, but there's a whole fundamental difference to how we design these zones so that there's less linear distortion. So if we look, or less difference between grid and ground. So every state gets one of these, a single statewide zone. What are we looking at here? Again, our color shading is that linear distortion. So here we're looking at plus or minus 50 parts per million, okay, or millimeter per kilometer, okay, or 100th of a foot per mile. You could do something like that, approximately, okay? Per 2 miles, sorry, 100th of a foot per 2 miles, approximately. A little bit of green, right? That's great, cool. But the thing about linear distortion is it's not error, okay? If all parties involved that are exchanging data, right? So if you're getting data from a survey team or whatever, if you and they understand what each other are doing, you know, enough to tell enough so that each person can tell their software what they want to get out of it, then there's really nothing wrong with linear distortion. It's a fact of working in a projected surface. You cannot avoid linear distortion. But the problem lies when people aren't on the same page. Okay, so that's the point of trying to get lower linear distortion so that people can start to ignore that difference. Okay, so with the statewide zone, sorry about that, I could feel a cough coming on, so move that microphone for a minute. With the statewide zone, you're not going to be able to do that. Ignore the grid and ground difference, but you're going to be able to work with data, any statewide data sets, and put them in one projection, right? So great, good. Compare this to what some people do, I know, is they use UTM as kind of a proxy for a statewide zone. So as you can see, less green, lots of dark. So if we compare again, the statewide zone that NGS that we designed is going to perform a lot better than using UTM as a statewide zone. Okay. I'm so sorry. I did not cough once all day, and now it starts when I've got a microphone, 2 inches from my face. Okay. So along with the statewide zone, a group of Ohio stakeholders, mainly the Ohio Department of Transportation, they did all of the groundwork, all of the analysis to design what? A set of 88 zones. Okay, so what does it look like? There it is. Say, boy, that looks like the counties. It is. It's a single SPCS zone for each county. Okay, so 88 zones, one per county. They numbered them alphabetically, like the old license plate stickers, right? The numeric county stickers. I don't even know if they do those now. I can't remember. So anyways, what we've got here, what we're looking at is combining all the counties together into one and looking at the same thing, linear distortion at the topographic surface, or the difference between grid and ground distances at that location. Lots of green, right? Lots of green. The design, the primary target design is to hit plus or minus 5 parts per million, right? Very well achieved here. At that point, you could start to, ignore that difference between grid and ground, okay? What would it look like if you compared this SPCS 2022, the 88 zone system, right, to the same statistical color shading, but looking at SPCS 83? Let's take a look real quick. So if we keep the color shading the same, right, wow, a lot worse, right? So we're looking at SPCS 83 again, the 2 zones, same linear distortion as the SPCS 2022 zones. So huge difference, right? Huge difference, big improvement. But I want to focus real quick on the fact that these 2 sets of zones, or these 2 separate layers, will coexist. Okay, what 2 separate layers? Up here, there's your 88 zones. Okay, 1 per county. Down here on the bottom, down here on the bottom, your single statewide zone. Both of these will exist as separate layers in our database and in our products and services, okay? And thus they will, as we publish the parameters out to the EPSG registry, the ISO geospatial registry, I think I got the name of that one wrong, the ISO, whatever, the ISO geospatial coordinate reference registry or whatever, as we publish the parameters out, the softwares, the tools that you use, the commercial softwares, right? They will be able to incorporate these zone parameters. And the plan is to have these online, the zone parameters, this year, so that our commercial partners can start incorporating them into their software. The thing I want to emphasize, though, is when you decide which way do I go, am I going to go with a statewide zone for all my data, or county by county? Obviously, if you have statewide data, you don't want to have 88 different zones. But what I want you to think about is your data, your goals, and your customers or constituents, okay? The smaller zones are not the best. There's less linear distortion, true, but they're not the best, okay? There's no best for this. It's about you, okay? And do keep in mind that geographic coordinates, right, behind the scenes, lat long, they are still your friend. That's what goes on behind the scenes in all of SPCS 2022 and SPCS 83 that we work in right now, okay? What I want to note real quick, though, is in our policy for SPCS 2022, we said that each state can have a maximum of 3 zone layers. Remember, so that's what we're looking at on that last slide, is those layers. So one layer is that statewide zone. Cool, NGS designed that for everybody, for every state. One other layer in Ohio, the other one that's preliminary right now, is the Ohio County Coordinate System. That's what ODOT came up with a name for it. So that's who designed I'll jump back to the 88 zone system, right? ODOT designed all this. They submitted all the parameters to us. We check it. We say, okay, cool. It looks good, right? So they're calling it the Ohio County Coordinate System, or OCCS. There's a third layer that could exist though, right? It would have to be discontinuous coverage, like maybe a large city. Tom, maybe the Cleveland.
I protest. I protest. No CRGS. No.
We'll skip that for anybody who's not familiar, but reach out if you want to hear about that sometime. I could talk about it. It's funny stuff. So as I wrap in on my closing thoughts, I'm just checking where I was at here. Oh yeah, so I wanted to say SPCS 2022. Remember, this is not just in Ohio. There's a map real quick here, and I wanted to emphasize this because we have folks from all over today. There's, I don't know how, I lost my slide within a total, there we go, 968 zones, okay, across the 50 states and US territories, okay? Everywhere from one zone in West Virginia, they decided to go with a single zone. That's cool, works for them, right? North Carolina, South Carolina, also single zone setups, but there's all sorts of different combinations of zones in those different layers that each state can have, right? Let me look at this next slide. I wanted to, oh, my words disappeared. Oh, well, whatever. I don't know what I had there. Trying to think of what I had. Anyways, I guess I just wanted to highlight the fact that, again, this is not just in Ohio. So here's a quick look at the statewide zone designs for all 50 states. So at the same linear distortion, you can see, if anything, this might highlight to you or make you realize, again, I've talked about it, this is all about a change in the design of these, right? These state plane zones. What we're doing is moving the projection surface, aligning it to the topographic surface. Okay, so as you get into areas of more extreme topography, right, you can't win until you cut the zone into smaller pieces. So at the statewide level, you see where there's more topography, there's more shift or change, right? Look at Indiana, so flat and lots of green, right? If we look real quick at a map of all of the, so every state in this map, it's showing the smallest zones or the lowest distortion zones for it. So pretty cool. You look at the Midwest, there's a lot of zones. There's probably 400 just across the Midwest, you know, so pretty neat. There was an, oh, this one didn't show it. I was going to say, not that it's of much interest to many people, but we also built a new Gulf SPCS zone called Gulf. So kind of neat. It was mainly for the oil industry, the drilling industry is who is interested in that. Oh, there's my statistics pop up. Not that anybody really wants to look at all of the statistics, but what we do, we have a design criteria for all of these. We're trying to push the distortion to the areas of least population based on census data. Okay, that's the goal here. All right, is to push those higher distortion areas to less developed areas. And I jumped to the wrong slide, but let me jump right here real quick as I want to close with a brief couple minutes on some units of measure. I want to point out that the survey foot is dead, right? Or no, long live the survey foot, right? But what do I mean by that? Okay, let's jump to the next slide. It's true, the US survey foot was deprecated as of the end of last year, okay? And the question then everybody likes to ask is, well, what should I be doing now? And I'll ask you, what should you be doing now about this? That's exactly what you should be doing, is nothing. Don't do anything about this now, okay? You should be doing nothing about SPCS or about the survey foot being deprecated now. This is nothing that you want to approach now, okay? Remember, this is all about the new datums, okay? Prepare for this to change with the new datums, okay? That's all you should do now, is be aware this is happening, okay? Understand at least a little bit of the difference. What makes the survey foot or S foot different than the international foot or I foot? It's 2 parts per million. And then understand that this is not enforced. Neither the National Institute for Standards and Technology or the National Geodetic Survey, are regulatory agencies. So what we do is we support education and outreach. We don't enforce rules like this. What I will say though is in the future, so tools like ours, NCAT, the NGS Coordinate Conversion and Transformation Tool, we will not have, it won't have the ability to output US survey foot coordinates in SPCS 2022 zones, okay? Chew on that for a minute while I jump real quick to what does it really mean, 2 parts per million? Again, we're talking, this matters in coordinates. When we're talking about millions, we start to see 2 feet, 20 feet of difference. In a 1,000-foot line, we're talking about less than 100th of foot of difference. Nobody can measure that reliably, okay? So this is about coordinates, not land records and distances and surveys. But I want to highlight in closing that, like I said, we will not support US survey foot in SPCS 2022, but it will always be available in all of our tools, products, and services for NAD 83 and 27 coordinates, okay? Since I know we're national, I want to say there's a regional advisor for every one of you out there. I'm the Appalachian Regional Geodetic Advisor, but there's 13 others across the country. We are here to support you, your constituents, our federal partners, any users of the NSRS. And if you have questions about this modernization effort, reach out now. There's my email, my phone number, and our website if you want to look us up.